All right. Hello and welcome back to the ongoing series of lectures on polymers. So, this will be the last lecture on polymer. After that, we'll move on to the next unit, that is metals. Till the previous lecture, we saw the differences between various types of plastics, right? To name a few, we saw various types of thermoplastics and various types of thermosets and saw some examples also. And in the end, we also discussed a little bit about what glass transition temperature for polymers are, why it is significant, and why we should know it. In this particular lecture, we will be starting our discussion on elastomers. So, the term elastomer might not be very much familiar with you, but the term rubber, this is familiar with you, right? So, rubber and its class, this particular class of polymers, this is associated with the term elastomers. So, formally in polymer chemistry, we call it as elastomers. Now, before actually going into rubber, let me just give you a brief idea on what copolymers are. I already, I think, told you in the previous sessions that what copolymers and homopolymers are. You see, in case of polyethylene, right, where there is a single repeating unit. So in such cases, because the repeating unit remains is the same one, and it the same thing keeps on repeating, right? But in case of copolymers, there may be more than one. There may be more than one repeating units, as we will see in case of synthetic rubbers. In case of synthetic rubbers, we will be seeing our some examples and their use cases of some of the materials that we'll see, where we will see the natural rubber has been modified with some other synthetic material, leading to the creation of another different whole sort of polymer. This type of polymer, because the repeating unit is not the same. So for example, if I write this like this, so here this is polyethylene. So here you see that this is the monomeric unit, right? So this will be repeating n number of times. But in case of modified or synthetic rubber, you will see this monomer does not remain the same. It may be two and even more than that sometimes. So having said that, let us now discuss a little bit about elastomers and their properties. Normally, you see when we talk about rubbers, what is the first thing that comes to your mind? The first, I think, idea that comes to our mind is basically elasticity, right? Elasticity, pliability, and all these type of things and all these type of terms come into our mind. Now the question is, why does it happen like that? Why are elastomers normally elastic in nature under certain conditions? Uh, the reason for it is that the natural structure of these polymers, the molecules, if you can see this particular picture that has been provided, this particular picture, see, the molecules are arranged in a coiled fashion. So when you apply some tensile strength, apply some tensile forces, and you try to pull it apart, right? Then it will form this long, if you can see this particular image, it will form this long chain, because it's just like a spring. Hmm. If a spring is basically how is a like this coiled. So if you want to pull this together apart from each other, what will happen? The spring will get deformed from this coil structure, and will if you pull it to a great extent, it will almost look like a straight line, like a chain. So this is exactly the thing that happens with elastomers also, rubber also. So if you pull it, it becomes this straight line structure, linear fashion, and once that tensile strength is being removed, this force is being removed from it, it will again go back to that original coil-like structure or coil form. That is why rubber is inherently very elastic and is pliable in nature. That is why it has so many uses in our industry and other industries as well. But in this scenario, I would just like to state that uh, non-natural rubber has certain problems. You see, like with any natural type of polymers, it is comprised a number of problems. Same is with rubber. That is why it needs to be, this natural rubber needs to be modified in one way or the other. Normally, one major modification method is vulcanization, but apart from that also, there are other techniques for modifying rubber. So we will see some of the types of rubber that is basically used in our industry as well. Now, the question is, can, can you basically name some of the areas where, like I asked you in the previous session, can you name some of the materials or FMCG goods or any other goods that is packaged in PET containers, or various polymers that are in use in various printing processes? So in this session, my question to you would be, can you name some of the application of rubber? We will see, we will be studying that only, but just to begin with, can you do one small exercise for yourself? Just, go on similar, make a list, right? On this side there will be printing method. Mm. Printing method on this side, and there will be the usage of rubber. Specifically, I'm saying usage of rubber. So here first you write offset. In what all purpose rubber is used in offset? It may be used in the making of ink rollers, main use, and also in case of blanket. We'll see in detail. So similarly, I told you one answer already. So similarly, can you mention it in gravure, screen, flexo, and all this? Can you mention all these things and prepare a list and send it to me via the Google Classroom forum or group? So do this exercise. We will be definitely discussing all that. Now, natural rubber is basically a polymerized isoprene, right? Uh, it is an amorphous type of solid and exhibits certain elastic property, as I already mentioned. It is also soluble in benzene and carbon disulfide. And natural rubber is very rarely used. Even if it is used, it is either used where you see, water-based inks that are used in flexography. In only those situations, natural rubber rollers may be used. Now, let me come to the point that why natural rubber is not that much preferred in the printing process, in any other printing process. Now, at high temp, because it is natural, it does not have any synthetic element to it. There are certain problems with it naturally. Like at very high temperatures, it becomes very hard, very soft and pliable, right? Very flexible in that way. And at very low temperature, it becomes very rigid. Now, the problem with this is, during, as I told you in the last lecture, if you remember, regarding the glass transition temperature, the glass transition TG for rubber is minus 70 degrees Celsius. So naturally, when in all possible use cases we will be using rubber, whether we are operating or using rubber in the form of ink rollers or in the form of blankets, we'll be using at a temperature higher than that only, minus 70 degrees Celsius only. So in that situation, it should not be, it is fine. I mean, there will be no problem. But what if the temperature goes so high that it becomes so flexible and so mushy that there will be some printing problems? What type of printing problems may occur? I will come at the end of the today's session in that. Now, natural rubber also has very low tensile strength, and it has swelling tendency. Swelling means when you are using it in conjunction with chemicals and water and all this, it will tend to absorb those chemicals and water, and it will try to swell up. So all this type of things will create, all this type of events will create some problems during the print production mechanism. So we'll discuss what problems that will create, but for now let us discuss what are the disadvantages of using natural rubber. And also, as I told you, it will try to swell up. It is also soluble in some polar type of solvents, organic solvents. So that is again a disadvantage, because many a times we use certain chemicals for cleaning the blanket, cleaning the ink rollers off, cleaning the ink from those rubber surfaces. But if during the cleaning process it starts to swell and absorb those chemicals, that will create some problems. Now, I said that rubber is elastic. Yes, it is elastic, all right, but only to a certain extent, right? If you try, if even if you have used a eraser, although it's not completely natural rubber, but I'm just giving you an example. If you have used a eraser, you try to pull it apart, it will come back. You remove the forces, and it will come back from its deformity and acquire its original state. But after a certain point, if you pull it to a great extent, break off, right? Same is the case with natural rubber. So that permanent deformation is a big problem in case of rubber. Another, in order to avoid this type of problems in case of rubber, natural rubber, it undergoes something which is known as uh, yeah. So this is basically the structure of natural rubber. As I told you, it's basically polymerized isoprene. So this is the isoprene, the monomeric unit, and this is the natural rubber. Now the yeah, this is what swelling is. I'll talk about swelling in a bit, but let us, yes. Now, in order to prevent this type of problems from happening in case of natural rubber, it undergoes the process of vulcanization. Now, vulcanization is done by heating natural rubber with 2 to 5% sulfur powder, and along with organic compounds like accelerators like zinc butyl xanthate and others. Now, other agents may also be added like sulfuric chloride, sulfur dioxide, hydrogen sulfide, all this. So what actually happens, all these type of problems, that is swelling and excessive pliability and all these type of problems, these type of problems can be avoided if the rubber undergoes some vulcanization process. So what is actually happening, if you see, sulfur is creating a branched like structure around the entire isoprene overlay. What this does, it reduces, as I already told, it has a, because it's an elastomer, it has got this a coil like structure. Now as soon as you pull it apart and you apply some tensile strength, it becomes linear in nature. But this is precisely the reason why some these excessive pliability issues occur in natural rubber and swelling occurs. If it's not a linear structure, if it's a branch structure with something like the sulfur atoms holding the other bonds together, if there is something to hold off the chains together, almost like a branch like structure, as you can see on the on the right hand side, this will prevent excessive swelling. This will increase the tensile strength of that said rubber. That is why it has been modified with the help of vulcanization. Okay. Now let us take a look at some of the copolymers that has been made with the help of rubber. So the first type of copolymer, that synthetic rubbers like the one that you are seeing, SBR, styrene butadiene rubber. Now they have advantages. They are suited for specific purposes. Now there are various methods or various techniques to prepare synthetic rubber. Now not all these synthetic rubbers will be used in the same scenario, as I will be explaining to you just now. What will happen is specific synthetic rubbers will be used for specific purposes. Now normally vulcanized rubber has good tensile strength, excellent resilience, and resistance towards various solvents, and it is not that easily soluble in polar solvents and all this. But specifically, if we talk about specific types of synthetic rubber, let us take some idea on what are some of the advantages, or what are some of the properties of using those type of synthetic rubbers. Now, so SBR is basically a copolymer. It contains two things. One is styrene and butadiene. So here you can see. So here you see there is not a single type of monomer, but two type of monomer. This is the butadiene part, this is the styrene part, right? So this becomes a copolymer. This is not a homopolymer anymore, where you can see the same type of repeating unit every time. Now this is has this type of SBR rubber has got very good resistance towards most chemicals, and high load bearing capacity, very good tensile strength issues and all this, and it improves the weatherability. That means it is not very much affected by moisture and other external climatic conditions and all this, and also very good towards crack resistance. So normally it is used in impression rollers of flexographic printing machines and offset blankets. Uh, Next, what we have is the neoprene. Neoprene is a polymer of 2-chlorobutadiene, as you can see. So this is normally it is known as neoprene, but it is resistant to oils and aging and other high pressure and all these things. Normally this is used in impression rollers of flexographic machines and also offset blankets. Now you may ask that, okay, what is the, so if you have already told that here SBR is also used as impression rollers of flexography and offset blankets and butydyl sorry, and neoprene is also used for the same purpose. What is the difference? Now see, as we will go on, and in other classes also of offset, you will see that within offset there are various types of printing mechanism. It may be heat set, it may be quick set, it may be cold set, it may be UV radiation curing. So depending upon the type of ink also, we choose the rubber. So for example, in case of if you are using UV curable ink, you may not choose this SBR type of rubber, you may choose the PDM type of rubbers, because the nature of chemicals that are used in the solvents, that are cleaning solvents and inks, that will determine what type of the main issue is the swelling part, right? And compressibility also, right? Because hardness, compressibility, as I will come to those issues, those particular points, you will see what those terms mean. But right now I'm just trying to give you an idea, brief idea, on what these particular terms, or what this particular various types of blankets are used. Now, another type of rubber which may be used is for our purpose is butyl rubber. So, butyl rubber is a polymer of 2-methyl propene. It has very good heat resistance and abrasion resistance and resistance towards aging and various other polar solvents, and as well as it has good insulation properties. Now, the reason, I mean, it's a relatively harder blanket, having a short hardness of 50 Shore. Now, we don't know as of now what hardness is and all that, but I'll be discussing it later on. So then you will be able to get some idea. Now, here butyl rubber is basically used where we are using very strong chemicals, very aggressive type of chemicals, where inks contain ketone and acrylates and all these things, which may be found in the UV type of inks. Because of this, because it is resistant to all these chemicals and all this swelling, it is used for the preparation of blankets and impression rollers, where we are using UV curable inks or harsh chemicals, right? That is the purpose use case of butyl rubber. Next we have EPDM, as I told you earlier. So here EPDM is also a your a type of copolymer. This has even better hardness and better resistant properties towards aggressiveness of the UV chemicals, especially the acrylate family of chemicals. Another type of rubber which is a polymer of acrylonitrile. Now this has got very good flexibility and has got very good resistance towards heat, aging, and also most important, it has got very good resistance towards high temperature also. Normally what we see in case of other rubbers, at higher temperature it becomes very much pliable. So here you see nitrile rubber has got very good hardness and a very good resistance towards high temperatures, making it suitable, very much suitable for different type of inks, that different types of printing purposes, that for which we may be using that these particular rubbers. Okay, so I think okay, now I think we will be coming directly to the blanket part that we are using in offset printing process. So what is basically your blanket? So if I can just draw a basic schematic of your offset printing process, what is the first one? I'll just pause here. Just remember from your basic printing class, what is the first one? What is the first um, uh, cylinder that in the printing couple in offset printing? It is the plate. Next one is the blanket. Next one is the impression. So the substrate passes between the blanket and impression. Plate contains the permanent inking master, so that transfers the ink into the blanket, and the blanket is made out of rubber, so that at least the top surface is made out of rubber. And in order to apply some pressure at the nip of the contact point between the substrate and the blanket, there is another cylinder which is known as the impression cylinder, which applies the pressure onto the substrate, so that the ink that is present, or the image that is present in the blanket, may get transferred onto the substrate, right? This is the basic process. Now, so what are some of the properties, or what is the purpose of this blanket that we know? Now let us take a very brief look at some of the structure of this particular blanket. This will be covered in detail in your other offset and planographic printing courses, but let me just give you a brief idea from polymer perspective of what the structure of the blanket is. So here you see there are multiple fabric layers. You see multiple fabric layers and compressible layers, and this is another layer. So depending upon how many plies of fabrics are there, the blanket may be referred to as either this number of plies or that number of ply of blanket. That is a specification of blanket, right? One of the specification of blanket, I'm sorry. So one thing for sure you can see that this basically contains multiple compressive layers, right? So, and on the top layer we have got this rubber surface. This is the elastomer, and the various types of rubber which are used in blankets for different purposes of printing that I've already mentioned in the previous one. Now, this the fabric that is woven is either either synthetic yarn, or it may be a different type of yarn. The textile piles that are coated with 6 to 8 very thin and coats of rubber compound. Uh, each coat is dried by evaporating the solvent with heat, and between the fabric piles, there is some, you can see here, there is some layer which basically acts as the compressible layer. Compressible means when the pressure is applied, it will, you know, it will get depressed to a little extent. So now let us take a look that what are some of the qualities that any offset blanket should be having for printing purpose. What type of rubber is used, that I've already mentioned. Now we are talking about what are some of the properties that the blanket should possess. Now it should have a good affinity towards ink, right? Why it should have a good affinity towards ink? Because the permanent inking master is basically transferring the ink onto the blanket. So the image which will be received on the substrate is actually coming from the blanket. There is dilitho, which is direct lithography, where the ink is coming directly from the plate onto the substrate, but that is, I mean, not very much in use nowadays. So normally in any printing process now, we see there is a blanket. Whenever there is some offset technology, it means the image has been transferred from the blanket, right? So if the blanket does not, the elastomer that has been used in the blanket does not have a good affinity towards the ink, then that will not serve the purpose, right? Will it? No, it will not serve the purpose. So that is the first quality that this blanket should possess. What is the second quality? It should, this picture is nice. The blanket should be easily able to release the paper, I think. Now the next property that all blankets, especially in the offset printing process, should possess is the property to be able to easily release the paper after printing. So here if you can take a look at the same thing, the printing couple in the offset printing process, paper is passing between the blanket and the impression cylinders, right? And the point of contact between the paper, blanket and impression, this is known as the nip, right? And the pressure therein is known as nip pressure. Now, after the printing is done, when the paper has come after, from this point, is coming away from the nip, right? After the printing has happened, if the blanket has got this tendency to form this bulb like structure, it is not, easily releasing. So this is basically your impression, this is basically your blanket, and this is the paper. Now after the printing has already been done and the ink has been transferred, if the, because of the, stickiness of, or the tack of the ink, or we are not concerned here mainly about the ink, but the tackiness or the stickiness of the blanket, if it is not easily able to release the paper after the printing has happened from the nib, then this will lead to all sorts of problem. Primary one of the problem is known as picking. Picking means, since the paper is not being released, some of the fibers, see, at this point of contact between when the paper has been printed, but still after, even after printing and the paper has been released from the nib, the blanket is not releasing the paper, it is pulling it towards itself. Here, because of this, because of this process, some of the coating and some of the fibers of the paper will start to get accumulated from the paper, and it will get onto the blanket. And over a period of time, a large number of fiber, a large number of amount of, this coating material, when it starts to get accumulated within the blanket, and the blanket is in again contact with the plate, and the plate is in contact with the ink form rollers and the inking train as such. So all these fibers will start to, move on to the inking rollers as well as the dampening rollers, and that will create a different sort of problem altogether. That will increase the conductivity, that will even lead to tearing of the paper, calcification problem. So all these type of problems will occur. Apart from this will also lead to some of the ink smearing, dot distortion, registration problems, streaks, all these type of problems. Piling means when a large amount of fibers and paper coating gets accumulated on the blanket. So picking is the problem where the blanket is not releasing the paper after the printing has been done. Piling is storing of, or accumulation of the dust, paper debris and paper fiber dust, due to picking onto the blanket and the inking rollers and other rollers within the inking frame. Next, the blanket should also be compressible. Now you see, this is the this is the plate and this is the blanket, right? As I told you, this point of contact is basically known as the nip. At the nip, the plate is applying pressure onto the blanket, and even after, at the point of contact between the, when there is the impression roller here, at the point of contact between the your blanket and impression cylinder over here, there is another point of contact where it is, the impression is applying some pressure on the blanket. So the point that I'm here trying to make here is that the blanket should be compressible. If it is not compressible like this, it will create some sort of bulge. Now, if it creates bulge, this will lead to a whole lot of other problem. It will not release the paper so easily. It will lead to ink smearing. It will lead to dot gain, dot distortion, and all these type of problems will occur. So let me show you one picture. I'll come back to this point later on, but here you see. So this is, here, although I have said that dot gain is due to hardness, which is true, but dot gain may also occur, right? This type of problem. See, the normal shape of the dot should have been like this, but it is actually becoming like this. It is increasing in size. It is distorting in shape. So all these problems will happen even if the blanket is not compressible enough. It will not allow for the smooth transition of the ink from the blanket to the paper. So that is another important point. So this is dependent on compressibility of your blanket, depends mainly, of course, the quality of rubber is important, but also what type of compressible layer you are using within the plies of the blanket, inner structure of the blanket, right? So this is basically your rubber surface. These are the fabric layers. So here we can see 3 layers of fabric. So 3 plies are there, but also there is some compressible layer. So you see, the individually the fabric layers may not be that compressible, but because of the presence of this compressible layer, due to the presence of this enhances, or provides the compressibility to your blanket, right? Next, another important point that we need to mention is that, as I already mentioned earlier also, that the affinity of the rubber should be towards ink. This should not be towards solvent. So if its affinity is towards solvent, then that will lead to now you may ask that where are these solvents used? Solvents are used definitely for, one is if you are using any form of ink that contains solvents, right? It may be organic solvent, inorganic solvent, etc. Now, if they contain solvent and they are in contact with the blanket, so solvent may get absorbed by the blanket if the blanket is more affine towards the solvent. Even after printing has been done, the blanket and the inking rollers are being cleaned with the help of some strong solvents. During this process also, the solvent may get absorbed. So that is what I am saying. The blanket that you are choosing should have strong affinity towards the ink and not towards the solvent. Should be able to repel such polar solvents. Like here, I have added these symbols because normally all these solvents that with which we are cleaning and which are being used in the your inks and all, they are mainly polar solvents, organic solvents. So that is why it should not have strong affinity towards, blanket should not have strong affinity towards the solvents, but it should have strong affinity towards the ink that you are using. So the next topic that I would like to focus on is basically the hardness. So what is hardness? How much the surface at least of the blanket is providing resistance to external pressure, right? That is what hardness is really. Now hardness is basically measured with the help of an instrument which is known as durometer. Now there are various units for measuring the hardness. So for example, here we see like for measuring the length, there may be several units like meter, centimeter, kilometer, etc. Here also we have several units for several purposes. One is showed A, showed D, shore B. So etc. Different types of shore measurements or units, shore units are basically used. What is the difference between this? Difference is between the cone, the angle that cone makes, conical head of the durometer makes, right? So here you see the cone makes an angle of 30 degree. So this is known as shore D type of durometer. Here, this truncated cone, this is basically a truncated cone. This truncated cone makes an angle of 35 degree. This type of measurement is known as, this type of durometer is known as shore A, right? A very simple method of measuring the hardness is basically just pushing this durometer onto the surface to an extent that it will no longer get more deeper than this, and you measure. So for example, this is the angle, right? This is the angle that the rubber surface makes with the 0 degree, right? So what is this angle? You need to measure this angle, and you do not need to measure this obviously manually. There is a head, or there is a measurement unit that is attached on top of the durometer, so that will give you the reading. So this angle that it makes, the hardness maker durometer makes with the blanket or the rubber surface, this is known as the hardness for that particular. So for example, this is 60 degree. Maybe another durometer, another blanket, not another durometer, but another blanket is making with the same durometer an angle of 30 degree. Okay, let us say this is 30 degree. So we have two blankets. Blanket 1 having hardness of uh, 60 degree shore A, and blanket 2 having a uh, sorry this is, another blanket which is making a hardness, which is having a hardness of 30 degree shore A, right? So which blanket do you think will be more harder in nature? Obviously the one which is having 60 degree shore, because it is not allowing higher angle. Means what? It is not allowing the durometer to penetrate, right? So that means what exactly? That means that the surface is providing greater resistance to any other material which is passing. So that is why this hardness is measured in this manner, and you can analyze the result. Normally what happens, any blanket is which is having a hardness of greater than 60-65 shore, they are considered to be hard blankets. Now hard blanket has certain advantages. It is providing better dot reproduction, because as you can see in the next slide. So for example, here hardness in this particular case is higher, and in this particular B is lower. You see the dot reproduction structure of both these blankets. So in case of A, which is, let us say, very hard blanket, maybe having hardness of 65 degree, and this may be having a hardness of 45 degree. So here you see this blanket is providing, the harder blanket is providing very sharp dot. That means what? The nip pressure, the point of pressure between the blanket and the substrate, that is not providing much wiggle room, and it's very stiff at that particular point, that point of nip. Because of this particular factor, harder blankets give better dot reproduction and sharper dot reproduction, as opposed to softer blankets or less harder blankets. So there you can see the different types of blanket hardness that is given, and what type of process they are basically used in. Now you see, in case of wave offset, I will not be saying all the answers now only, because I will be asking you some questions. In case of wave offset, right, you can see here that the hardness is highest, but in case of slower proofing machines, the hardness is kind of the lowest, although both may be considered hard, because they are all greater than 70 degree shore. But in case of wave offset, the hardness is highest, but in case of your slower proofing machines, the hardness is lowest. So can you tell me what all things are the contributing factors here? Why does wave offset demand a harder blanket than your proofing machine? This is a question that I'm asking you. You need to find the answer to it and send me your answers through the Google Classroom platform. Okay. Now next, I will also be talking about some of the cleaning mechanism of the blanket. You see, if you go back to the slide, yeah, if you go back to the slide, as I already told, that the blanket should not be affected, or should not have great affinity towards polar solvents which are found in inks and cleaning agents. So in this context also, I would like to mention that whenever you are cleaning blanket, you should make sure you are not using any polar organic solvents which may be having adverse effect on the lifespan of the blanket. By these type of polar solvents, normally what happens when they come in contact with the blanket starts to absorb them and it swells up and it will lead to a whole lot of problem, right? So these type of things should be avoided. So benzene and other toluene and these type of very strong harsh type of cleaning solvents or organic solvents should be avoided. And mineral oil, which is having high boiling point and very long trying to dry, these type of solvent may also be absorbed by the blanket and over the period of time, and it may ultimately swell the blanket. So other materials like ketones and turpentines, they also causes the blanket to swell. uh, Benzene, carbon disulfide, they dissolve in rubber. They try to swell the blanket. So whenever you are trying to use some solvent that has to be used for choosing a solvent that has to be used for cleaning blanket, you should be well aware about the constituents of the particular material, and you should avoid these type of ketonic solvents and aromatic solvents. This will ultimately reduce the lifespan of the blanket, and it will reduce the quality of printing as well. So when your blanket is basically swelled up, so this type of problems, this bulging problems and all this type of problems will occur. So compressibility will reduce, dot distortion may happen, and the quality of printing will go down. So all these type of problems will happen. So I think we have completed here all the qualities that the blanket should possess: compressibility, hardness, then affinity towards ink, not affinity towards your organic solvents, and ability to leave the paper, different types of solvents which may not be used for cleaning blanket, the recommended levels of shore hardness for different types of printing processes. So we have completed a brief overview on different types of blankets properties, and also the types of rubber that are used in different printing processes, that also we have completed. So with this, we have completed finally the polymer unit in Printers Material Science 1.